Okay, this is the solutions for the formal homework 3. Okay, the first few questions were multiple choice. Each one is worth 2 marks. Okay, question 1. What is the gradient of the line perpendicular to the line 4x minus 8y plus 3 equals 0? Okay, so if it's perpendicular, it's going to involve m1, m2 equals minus 1 and flip and invert. First thing I need to do is write this thing in the form y equals mx plus c. So let's bring that stuff across, and I've got minus 8y equals minus 4x minus 3. That's by bringing them across and changing the sign. I can then change the sign of everything. 8y equals 4x plus 3. Y equals 4 over 8x plus 3 over 8. So that's me writing the thing in the form y equals mx plus c. Simplify the thing down. Y equals 1/2 x plus 3x. So we can see there that the gradient is 1/2. So flip and invert 1/2 on its head, change its sign, and that's going to be minus 2, and that's option B, 2 marks, 2 or 0. Okay, question 2, multiple choice again, 2 or 0 for the correct answer or not. F of x equals x squared minus 1. Question is looking for me to find f of x. Well, f of x is x squared minus 1, so it's f of x squared minus 1. What's the f function? The f function is whatever's in the bracket, you write it down, you square it, you take away 1. Whatever's in the bracket, you write it down, you square it, and take away 1. Whatever's in the bracket, you write it down, you square it, and you take away 1. Okay, and then need to expand this thing out. So it's going to be x squared minus 1 bracket x squared minus 1 minus 1. So it's going to be x to the 4 minus 2x squared plus 1 minus 1 will give me x to the 4 minus 2x squared, which is option D. Okay, question 3. The midpoint of a line joining these 2 points, A5 and 5B, is 2, 4. Find the values of A and B. So remember that the midpoint is given by x1 plus x2 over 2, and y1 plus y2 over 2. Okay, so x1 plus x2, A plus 5 over 2, y1 plus y2 over 2. That's equal to a midpoint of 2, 4. So this will give me 2 and that will give me 4. A plus 5 over 2 equals 2. A plus 5, bring that up, that will be 2 times 2. A plus 5 is equal to 4 and A is equal to 4 minus 5, that's minus 1. 5 plus B over 2 is equal to 4. Bring that up and multiply. 5 plus B equals 4 times 2 is 8. B is equal to 8 minus 5. B is equal to 3. A is equal to minus 1. B is equal to 3. And that is option B, 2 or 0. Okay, question 4. Question 4, here are 2 statements about the line joining P and Q. P is the point 0, 5 and Q is the point minus 3, 5. Okay, statement 1, PQ is parallel to the y-axis. Okay, that means it's got the same gradient. What's the gradient of the y-axis? Well, there's the y-axis, that's kind of undefined, that's kind of infinite gradient. Okay, that's statement 1. Statement 2, the length of PQ is root 109, and if I put those 2 lines, that indicates that I'm talking about the magnitude, the length. Okay, first thing, let's investigate statement 1, which is in reference to the gradient. So 5 minus 5 over minus 3 minus 0, 0 over minus 3, and the gradient is 0. That means it's actually parallel to the x-axis because it's got a 0 gradient, which means it's not parallel to the y-axis, so statement 1 is not true. Okay, statement 2. Okay, so we've got a point 0, 5 and we've got a point minus 3, 5. Well, they're the same height, and if you travel from 0 along to minus 3, you've travelled 3 units. You've not travelled root 109 units. Statement 2 is not true either. So, correct answer, 2 or 0 is A. Neither statement is true. Okay, question 5. G of x is given by 1 over x squared minus 4. what's a suitable domain of G? What we're thinking about here is that you cannot divide by 0. Okay, so x squared minus 4 cannot be 0. That's a difference of 2 squares, so x plus 2 bracket x minus 2 cannot be 0. So x plus 2 cannot be 0 and x minus 2 cannot be 0, which means x cannot be minus 2 and x cannot be 2. Those are the restrictions on the domain, and that is option C, 2 or 0. Okay, question 6. We've got A and B are the points minus 3, minus 1 and 5, 5 respectively. Find the equation of the perpendicular bisector of AP. Okay, so the perpendicular bisector, well, it bisects the thing and it cuts at a right angle, so we don't need point gradient. So let's go after the point first. That's the midpoint. So it's going to be an average of the x and the y coordinates. Minus 3 plus 5 over 2. Minus 1 plus 5 over 2. Minus 3 plus 5 is 2, 2 over 2 is 1, minus 1 plus 5 is 4, 4 over 2 is 2. So the midpoint then is 1, 2, and now we need to find the gradient. So let's first of all find the gradient of AB, then flip and invert. That's going to be 5 minus minus 1 over 5 minus minus 3. 5 minus minus 1 is 6, 5 minus minus 3 is 8. 6 over 8, simplify that down 3 quarters. It's then m1, m2 equals minus 1. Flip and invert, and that's minus 4 over 3. Okay, so it's then y minus 2 equals minus 4 over 3 bracket x minus 1. Multiply through by the 3, 3y minus 6 is equal to minus 4 bracket x minus 1. 3y minus 6 is equal to minus 4x plus 4. Bring that across, and 3y is equal to minus 4x plus 2. Final answer. Okay, let's have a think about where the marks would be allocated to this question. Right, so let's go for 1 mark for the midpoint and a second mark for getting as far as the correct gradient. That would be my second mark, and the third mark would be manipulating this equation and getting to the final answer. Third mark, 3 marks in that question. Okay, next question. Find the size of the angle 8 degrees that the line joining A and B makes with the positive direction of the x-axis, and we're given a point A which is 0 minus 1 and a point B which is 3 root 3, 2. Okay, we first of all need to find the gradient. It's going to be 2 minus minus 1 over 3 root 3 minus 0. So that will be 3 over 3 root 3. They cancel out to leave me with not root 3 but 1 over root 3. Okay, so we're talking about gradient and angles in the positive direction of the x-axis. That can only ever mean one thing, which is m equals tan theta. Tan theta equals the gradient, which is 1 over root 3. Now that's an exact value, which is 30 degrees. You haven't come on to exact values yet. Okay, so let's go for that being a 3 mark question again. Okay, 1 mark for correctly identifying 1 over root 3. Second mark for coming up with m equals tan theta. You probably use the calculator at that point if you got that one right, which is fine for the time being. That would be your third mark. Okay, question 8. And we've got the function f of x is given by x minus 1 and the function g of x is given by x squared. Okay, part 1, that would be a 1 marker. Find f of g of x. So that's f of x squared. What's the f function? The f function is whatever's in the bracket, you write it down, you take away 1. Whatever's in the bracket, you write it down, you take away 1. Okay, that's definitely just 1 mark. Okay, part 2 is find g of f of x, and this will just be 1 mark again. So g of f of x, that will be g of, what's f of x? X minus 1. Okay, so that's going to be, what's the g function? Whatever's in the bracket, write it down and square it. Whatever's in the bracket, you write it down and square it. Now that's absolutely not equal to x squared minus 1. You don't square both terms here. You expand the bracket and that's x squared minus 2x plus 1. Definitely, again, just, well, probably 2 marks this time. 1 mark for getting as far as here, and the second mark for here. 1 and 1. Okay, the question then says h of x equals f of g of x plus g of f of x, and the question then goes on to say to show that h of x is equal to 2x squared minus 2x and sketch h. Okay, so definitely just 1 mark for the first bit to prove that. So it's x squared minus 1 plus x squared minus 2x plus 1, and that gives me 2x squared minus 2x. Okay, definitely just 1 mark for that. Okay, next question, I'm looking to sketch h. Okay, so let's do a wee bit of curve sketching with differentiation here. Okay, let's first of all check the x-axis. Okay, that means that the y-coordinate would be equal to 0. So that's 2x squared minus 2x equals 0. Okay, highest common factor then would be 2x bracket x minus 2 equals 0. 2x equals 0 or x minus 2 equals 0, which means x is 0 or x is 2. Okay, so that gives me my points that cut the x-axis, which is 0, 0 and 2, 0. Let's now check the y-axis by making x equal to 0. So that will be h of x equals 2 lots of 0 squared minus 2 lots of 0, which gives me 0, which is the origin again, 0, 0. Okay, let's put that aside. That's where I cut the axis. I cut the axis at 0, 0 to 0. And now let's go after the stationary points. Okay, so that means that I need to differentiate the function. So that will be h dashed x equals 4x minus 2 equals 0, remember, and then make the statement for stationary points h dashed x is equal to 0. Okay, that's then 4x is equal to 2, x is equal to 2 over 4, and I'm going to simplify that down, x equals 1/2, so my stationary point occurs at x equals 1/2. Okay, let's get the y-coordinate, sub that back into the original function, 2 lots of 1/2 squared minus 2 lots of 1/2. So 1/2 squared is 1/4, so that's 2/4 minus 2 times 1/2 is 1. So that's 1/2 take away 1, which is minus 1/2. So my stationary point then I've got is 1/2 bracket minus 1/2. Okay, we're now going to set up a nature table. So x, h dashed x, and slope. Okay, so the stationary point is at 1/2, so that's 0 gradient, and the slope's going along the way. Okay, before a half, neighbouring value could be 0, and after half could be 1. We're putting that into the differentiated function. So 4 lots of 0 minus 2, that's minus 2, that's a negative result. Okay, then 1 would be 4 lots of 1 minus 2, that's 4 take away 2, that's a positive result. So we can see that we've got a min-turning point at 1/2 minus 1/2. Okay, so let's sketch the thing out. So I cut at 0 and 2, and I've got a min-turning point at 1/2 minus 1/2. Okay, so in terms of marks there, let's go 1 mark for getting both the y and x axis, so 0, 0 and 2, 0. So 1 mark for that and 1 mark for that. And a second mark for differentiating the thing and making it equal to 0. Third mark rather. Okay, so another mark for that. And then another mark to get the stationary point, and another mark to get the y-coordinate of the stationary point. Another mark to get the fact that it's a min-turning point, and then a final mark to sketch the thing out. Okay, so the sketching part of the question is going to be worth a total of 1, 2, 3, 4, 5, 6, 7 marks. Okay, question 9. We've got a graph as follows. Y equals g of x, and it's got a turn point here of a minus 2. It goes through the y-axis at 1, and it's got another turn point here of b3. Question then says sketch minus g of x. Okay, so that really is just going to be a 1 marker. So it's a flip across the x-axis. A minus 2 will now go through A2. I'll now go through minus 1 on the x-axis, and B3 will now be B minus 3. So dead simple, you need to get each of those, and that will definitely just be 1 mark. Okay, part 2 then says to draw 3 minus g of x. Okay, so we've got minus g of x, that's in red, so let's go in green now. So, what's 3 minus g of x? Well, it's the same as minus g of x plus 3. That might be a better way to think about it. So we're going to shift everything up by 3 units, so minus 1 will shift up to 2. A2 will now shift up to A5, and B minus 3 will now shift up to B0, which would need to be on the x-axis because that's what a y-coordinate of 0 would be. Okay, so that's really going to be worth 3 marks. Okay, so first mark would be to get the 3 points, and second mark would be the basic shape of the curve. So in fact, just make that one worth 2 marks. Okay, so 1 mark to get part A, and then 2 marks to get the second one. The first mark being the correct 3 points, and the second mark being that it's been shown to be shifted up and it's got that shape.